Mr. Thompson. You're a smarty pants. I'll let you try a few on your own.
All right.
I don't know what color you want. You pick. So yours is going to be aluminum, which is Al,
Okay.
and then P. I'll even help you out. Aluminum is in group 3, so you don't have to look it up.
Okay. So I need 1, 2, 3.
And phosphorus is in group 5 or 15, whichever one you want to look at.
So I need 1, 2, 3, 4, 5.
Correct.
All right. So I want to take the electrons from the aluminum and give them to the phosphorus. So I can go, and I'll move this one here and that one there.
Perfect.
Okay. And okay, so I'm done.
But you've got to also write out down here that aluminum's lost his 3 electrons.
Okay.
Remember how we did that?
So we did plus 3 because it lost 3.
Correct.
And phosphorus gained 3, so it has 3 extra negative charges, minus 3.
Correct.
I think I'm still missing something. Am I?
You could put some dots around that if you wanted to, just to show that he actually has 8 around him.
I think I will until I get this down all the way. And then I thought you had that too.
We have some brackets. It's not necessary to put brackets. You can put them there, you can't. It's up to you. Now, we've been doing where it's just, he's been giving, he's been taking, and it's exactly what they need. So we're going to change it up and we're going to do something a little bit different now. So the next one we're going to try is Mg and Cl. So when we put magnesium and chlorine together, they form magnesium chloride. Okay. So we're going to go through this a little bit quickly. So we know that magnesium is in group 2. He's got 2 dots on him, right?
Right.
Chlorine is in group
7.
7. We just did him.
Right.
So we've got 1, 2, 3, 4, 5, 6, 7. Now, remember he wants to give because he's got less than 4. He wants to take because he's got more than 4. So I go over here and chlorine's only got 1 empty spot to give to, but magnesium wants to give all of his away. And that was the whole point of the game None or 8. He wants to have none at all, and he needs to have a total of 8. So I'm still not following the rules because chlorine hasn't gotten rid of all of his electrons. So how can I get rid of 1 more electron?
Could you get another chlorine?
I could. We could invite another chlorine in. And we're going to come down here. Again, he gets his 7 valence electrons. And then we'll now go down here. So we have transferred both of our electrons. Magnesium now has no electrons, and each chlorine has a total of 8.
Okay.
Okay. So when we would write this, and actually write our formula because it's just been a 1-to-1, we would actually write it as MgCl. And since we have how many of them?
We've got 2 chlorines.
2, so we could actually write it just like that so you get familiar with the way that the formula looks.
Okay.
Okay, so we've got one less one that I'm going to let you try.
Yay!
I know you'd be excited. Yours is going to be Ca, so calcium,
Ca.
and phosphorus, P.
And phosphorus. All right. Calcium has 2. And phosphorus still has 5.
Correct.
Okay. So I can move, I still want to move my electrons. So calcium is going to get rid of its electrons and give them to phosphorus. But I ran out of electrons, and I still have one. I have one here.
Okay, so what did we do last time if we needed somebody to give electrons to?
Well, last time we added another chlorine. So I can add another calcium?
Exactly.
Okay, so here's calcium with our 2. It's going to get rid of its 1. But now I've got an extra one here.
Okay, well, we've got to give them all away. So what should I add next?
So then I guess in this case I can add a phosphorus.
Correct.
Okay, so here is phosphorus, and we're going to get rid of this and bring it here.
Good.
That one's gotten rid of all of the electrons here, but we still got to get some here. So I can add another calcium.
Another calcium.
Okay. So calcium right there. I've got 1 and 1.
Perfect. So let's look at it. Do all of my calciums now officially have no electrons because I've given them all away?
Yes.
Okay. Do my phosphorus have access to 8 because I've taken them?
Yes.
Then we're good.
Wow, that's wild.
You're welcome.
Okay.
All right, so we still have that last step to do where we actually write down how many calciums, or what calcium's lost, and what the phosphorus has gained for their electrons.
Okay, so I've got calcium, and it lost 2. Here's calcium. Here's calcium plus 2 plus 2.
All right.
And then phosphorus, and 2 of those in each one, gained 3.
Correct.
Okay.
Now let's look at something real quick, just to kind of hit a point home. I've got plus 2, plus 2, plus 2. So if I were to add up 2 plus 2 plus 2, what would it be equal to?
6.
Okay, so we've got a plus 6, and then I've got minus 3 plus a minus 3.
6.
Oh, you're good.
Minus
So we've got,
6.
oh, minus 6. So if I've got a plus 6 and a minus 6, what's my overall charge?
0. They're going to cancel out.
Exactly, and that would happen on every single one that we've done, that they would actually have a neutral charge because ionic compounds have neutral charges. Last thing that you could do if you wanted to write this in the actual formula, which we will get to in the future, is since we have 3 CAs, write it in brown. So we have CA with the 3. That subscript tells me I've got 3 of them, and then I've got P phosphorus, and how many did I have?
2.
2, so I write a 2, and that would be my formula.
Cool.